Hello boys and girls, today we're going to learn how to write a formula for an exponential function when we're given any 2 points. We can write an exponential function through any 2 points as long as they are not crossing the x-axis, so like a positive and a negative output. But in this case we're going to work with only positive outputs, and so it should be pretty easy. So let's take a look at an example here. 0, 4 is 1 point, and 3, 6 is our other point. Now you'll notice on the homework tonight I expressed these points in a number of different ways, right? Sometimes as points, sometimes as function notation, sometimes as on a graph, sometimes in a table, but it all means the same thing. So in this case, what we need to find is the initial value and the growth factor. Now the initial value is actually given to you here, right? We know that 4, because it goes to 0, is the initial value. And so all we really need to find is the growth factor. We'll take a look in a few minutes at how to find an exponential function, right, when we don't have the initial value given to us. So let's take a look at how we find the growth factor here. With a linear function, what we look at is subtracting, right, the rate of change, the idea of slope. We would subtract and compare. Right? But in this case, because we're dealing with repeated multiplication of an exponential function, right, we're actually going to divide. So we're going to set up 2 identical formulas, or 2 structurally similar formulas, right? With y equals ab to the t. So we have 2 of these we're going to set up using the points that we're given. So first I'm going to put in 6, notice that 6 is my y value, equals a b to the third. 3 is my t value here. And then I'm going to have another equation using my other point. 4 equals a b to the 0. Now, when I do this, right, I need to divide these 2 equations, interestingly enough, instead of subtracting them like we might do in a linear function. So I'm going to divide both equations by each other. Now, you'll notice that the a's, because we have an a on top and an a on the bottom, they both cancel. And we're left with b to the third power on the right-hand side and 6/4, or 3 halves, on the left-hand side. So to solve for b, to solve for our growth factor, right, we need to simply cube root both sides. That cancels. We're left with b equals the cube root of 3 halves. Now, the cube root of 3 halves is some terrible irrational number, right? You can leave it as that, right? But you can also you can leave it as cube root of 3 halves if you're trying to find the exact solution. You can use your calculator to figure out what that is if you are looking for an approximate solution. We'll talk more about that in upcoming chapters. So that's very simple. When we're given the initial value, right, we just take that value, which we said was 4, and we have f of t equals 4 times the cube root of 3 halves to the t. And that is our final formula. All right, very simple. It's a little more complicated when we're not given the initial value. Right? When we, in other words, when we have we don't have the point that has a 0 in it for input. So we're going to take a look at another example here where we do something very similar, right, but not quite the same. So let's say we had 1, 4, and I don't know, let's do 3, 6 again. Okay? So similar outputs, or same outputs, but different inputs, right? The first point, instead of being 0, 4, is 1. So we can do the same method that we used last time of setting up 2 equations. We call this the divide and conquer method, right? So that's what I call it. So we're going to set this up again. Notice I always use the bigger input on top. So we have 6 equals a b to the third. I like to put the bigger input on top simply because then I don't have to deal with negative exponents. And then I also have 4 equals a b to the 1. Okay, so in this scenario, right, once again, we're going to divide both sides by each other, and the a's cancel again. We're going to come back to a in a minute, but for now, the a's cancel. Okay, and then we have b to the second by subtracting the exponents, and once again, we have 3 halves. Okay, so now to solve for b, we just square root this time. Oops, square root, sorry. And that is our value for b. The square root of 3 halves is, again, can be turned into an irrational number. that's not particularly bad. Well, it's irrational, so it's always bad. But you can turn that into an irrational number if you'd like. It's up to you. Now we need to work through and find A. So we want to take this value of B and put it back into the original equation. Now you'll notice I've chosen to put it back, that goes into B, not A. You'll notice that I've chosen to put it into the smaller of the two exponents, right? B to the first rather than B to the third. I do that simply because it's a little less work and there's not so much going on here. Okay, so we plug in B here, we get 4 equals A times square root of 3/2 to the first. This is great because we have the first power here, right? So I don't have to worry about doing anything, really. It just stays as the square root of 3/2. Now I'm going to do 4 divided by the square root of 3/2 equals A. I don't want to leave that that way, right? That's bad form, right? You can turn this into an irrational number if you're estimating, right? If you're approximating, but we can also rationalize this, right? By multiplying top and bottom by root 3/2. So we have 4 root 3/2 over 3/2, which then gives me 2/3 on top, 2 on top. And then that gives me 8 root 3/2 over. So it's not pretty, right? And often in exponential functions, the answer is not pretty. We have to get used to dealing with these ugly numbers, right? Both in radical form as well as irrational. Okay, so that's called divide and conquer, and that's a way for you to get the equation for any exponential function, no matter what 2 points we're given. Okay? If you have any questions, you can ask me on the Facebook page, and I'll get back to you. You can do this. Goodbye.